Okay, so let's hit the road. Let's see what it takes to actually deal with containers, right? So let's go ahead with the demo. Before we actually execute any Docker commands, we need to actually install the Docker desktop onto our PC. So go to docker.com, go to products, and you will see desktop. So this is what you need to actually install onto your machine. So download the Docker desktop for Windows or Mac, and then once you install, you're going to get a little um, whale icon here, which actually indicates that basically you have a successful Docker installation. So if you actually hit about desktop, it's going to show you it's not only installed the Docker desktop, but then it also have installed some of the other components like Kubernetes and some other Docker Compose and other things, which is basically part of the Docker ecosystem, right? And also there's a bunch of settings with Docker. So you might want to adjust that before you actually start proceeding. Basically, they are into setting up a proxy. So if you are in a corporate firewall environment, you might need to look at your proxy and then ensure that the Docker starts up always when you log in and things like that. So once all that is set, you can now start digging into actual Docker execution itself. So let's see what it takes to bring up an image of Docker and then run. Okay, so one thing you need to remember always is like whenever you want to deal with Dockers, it's always good that you start the command line interface with the admin privileges. So I'm starting that with the administrator privileges. So let's see what I have on the system. So when I say Docker, it should take a while. Okay, so I have Docker installed. Okay, I have 1903.5, which is good. So I might already have a couple of images. Let me check what I have. If I type Docker images, it's going to give me that I have two images. So basically, one of them is the hello world, and the second one is basically the server core. So these are two images. So I'm going to demonstrate execution of hello world. That's the simplest app. So let me remove that from my system. RMI removes the image. So minus F will force if it is running. Okay, good. So that's removed from the system. So as I already mentioned, you always need to visit Docker Hub for any kind of images that you want to pull from Docker. I mean, Docker Hub is the like kind of the only repository where you can actually go for and get the images what you want. You can hit the explore here, and here on the left hand side categories, I actually want only Windows. So just a little below here, you can see that there is a hello world example. So it's just an example of minimal Dockerization. So click on that and you're going to get some information about what it is based on. So it's based on um, basically a nano server, and then you can actually also see that there is a copy paste utility here for you to actually help you to copy the command which needs to pull this image. So let me copy that. So copy that. So let me go to my command line. Let me clear the screen. Let me paste that. So instead of pull, I'm actually going to replace this with a run command. So if I run hello world, if it already finds that the image is not present, It's going to automatically download for you and then run it. So let's hit enter for our first Docker Hello World example. There you go. So it says that it cannot find that locally. So that could be because I have my proxy set and I'm not on my corporate network right now. So let me just go and uncheck the proxy settings here. I don't need a proxy. So it takes a while for the Docker to basically back up. So again, you get a notification here saying Docker is up and running. So I'll run the command again. So it says that it's unable to find the Docker Hello World latest image, and then it now downloaded it, and it already gave you a message. So hello from Docker. So let's read what it says. This message shows that your installation appears to be working. That's good. To generate this message, Docker did all this following. So the Docker client, which is the command line interface, contacted the Docker daemon. So Docker daemon is a service which is running your machine. The Docker daemon pulled the hello world image from the Docker hub, which you just saw, and then the Docker daemon created a new container from that image. So new container is just an instance of the image which it downloaded, and it executed, and then it produced an output, and then that output was streamed back into your terminal. I mean, that's what you're seeing it on the screen. So basically this is just a one-time execution, and basically Docker is meant for that. So if you want to execute something, you just start it off, it does its task, and it just comes back. So now, what really happened? I mean, basically, we can't really know what process has started, how did it get this message to my screen, etc. So let's change a little bit. So let's see what's running in Docker now. So ps command actually tells you what all containers are running. So if you see, I don't have any containers running. So let me run the same command again, and this time let me actually add a ping command, and I ping to myself. So again, all these commands execute on the Docker instance. So it's a command for the container and not for your command line. When I run this, there you go. So if you actually see now, there should be some process running. So where do you think the process is running? Let's see in our task manager, where's this process? So if you look into your task manager process list, you have the VM process, basically the virtual machine, a daemon, virtual machine process which is running. Let me find that for you. There you go. So there's a virtual machine process which is running. As you can see here, the virtual machine worker process. So this command, this Docker image is actually running inside a virtual machine. And then your Hyper-V is actually the Hyper-V layer is actually executing, although you don't have any virtual machines created here which can be listed here. Basically, it's the Hyper-V layer which is being used for the virtual machine worker process to run, and that in turn is actually running your command what you actually saw. So let me just open another command line, and then here let me run the same command again. Docker run hello world, and then ping. So as soon as I run this, you should see more of these processes again, right? So let me go back to the virtual machine processes. As you can see, basically you are actually seeing more and more of these processes running. So let me now stop this. And if you see Docker PS, you see that there are two Docker instances running. Even though you came out of that um, ping command, it's still running. So let me stop these two. I just need to use the first few characters to identify a container, and that will be 4A7, and then Docker stop CC8. There you go. So let me go back to my task manager. As you can see, there were four virtual machine processes which were running, and all of them have exited now. Okay, so what actually happened? So if you actually see the history, basically Docker came from Linux world. So let's see what was the architecture in Linux, or what is the architecture in Linux right now. So as you can see, basically there's the top layer. You can see the Docker client, the Docker compose file, Docker registry, and the Docker swarm is basically the orchestration part of Docker. So all these are like no application on top of or basically which interfaces with the Docker engine, which is the core. So as you can see, there is a Docker engine and it exposes a REST interface where all the other UI or client components connect to that. And the Docker engine itself has a lot of libraries. Basically, there is a network library, plugins, a container, and then there is also a container D plus run C layer, which interacts with the operating system. So the operating system itself is the Linux operating system. You have namespaces, the union file system, and other OS functionality. So if we actually look at the architecture in Windows, it's pretty much the same. So basically, you have the similar um, architecture in Windows, except that there is no Linux layer what you saw in between. If you actually go back and forth, you see that there's almost very little difference between the architecture in Windows and then Linux. Basically, there is a Docker engine and all the upper part, the Docker client and other components, they are all the same. There is also a REST interface. The Docker engine remains the same. The libraries within the Docker engine, it's all the same. Probably it's re-implemented for it to work on Windows. But then the other part is like no, in the namespaces is actually the mapping of job ID descriptor in Windows. So using the job ID concept, the security descriptor, Windows is able to map namespaces, and then the layer capabilities like union file system and other things are like kind of extensions built on top of the Windows NTFS file system. And of course, all the other voice functionality remains the same. So it's pretty much the same way where it runs in Windows, but there is a difference. Basically, Windows supports two modes of operation. One is the container server itself serving as a no native host, which you see on the left hand side. So there is a direct container host which works on the server version of 2019, and then there are containers above that which directly interacts. If you come to the Hyper-V isolation method or Hyper-V mode of operation, there is this core container host which is at the bottom, and then there is a hypervisor layer which is actually on top, which gives you a container in each virtual machine. So what you just saw in my machine is a Windows 10 machine. It's basically a virtual machine which is actually hosting the container. One core feature of Docker, or basically the fundamental principle of Docker, is based on isolation. So it provides you basically the process isolation. So as I explained to you, either it uses the Hyper-V way of actually isolating because you are already in the VM process, or it actually uses a job descriptor or a job ID and completely isolates the processes. In order to show that, I need to actually switch to a native Windows 2019 server machine where I can run the container for you, and I can show you that when you actually execute a process like the ping command which I showed you, the ping command actually appears in the list of tasks on the host operating system. Although it appears on the host operating system, you cannot reach to that directly. It's completely shielded, and only communication is via the Docker engine. So it provides you a complete process isolation. And then it also provides you storage isolation. I'm going to go into that a little later. When you actually say storage isolation, it is a reserved space within your own drive. So it could be a C drive, D drive, or system drive, where it reserves some space for your containers to reside. And this is not really something which your host operating system would interact with. Although it is visible for the host operating system, it is not really intended to be used by any of the host processes. And then finally, the network isolation. So how do you think that this kind of isolated VM or the container actually is running, and can it and how will it survive if it doesn't interact with the other components or the host operating system or even the other VMs in the network? So obviously you need network, and then network is also completely isolated. If you actually come to the Windows 10 desktop environment, you can actually see that there is a virtual NIC, which is basically, let me open the network adapter. So if you go to the network options, you can see that there are a default switch and a Hyper-V switch which is already identified, already created for you. So if you go here, basically this is how the network interaction between the host and the containers itself happen. I'll examine the network details a little later. I just want to show you that basically it creates a virtual network within um, your own host to ensure that there is a complete ecosystem of the Docker containers, and it allows you to interact with not only the host but also within each of these network container instances. Okay, so let's do a little bit more interesting stuff. Let's try to install an IaaS server. So if you type Docker images, we already have a server core here. I have pre-downloaded this image because it's 4.81 gig in size. So all we need to do is basically run that Docker command. So docker run mcr.microsoft.com/windows/server core, and then we need to give a tag, because if you don't give anything, it's going to pick the latest, and that's not what we want. So we need LTSC 2019 image, or the tagged image. So I'm going to give LTSC 2019. When I hit enter, um, let's see what happens. Well, as you see, there's just an output which indicating Microsoft Windows version 10 and a copyright message, and that's about it. There's nothing else seems to be happening. But what has actually happened is like it's actually started a container based on that image. If you do a Docker PS, you're going to see that there is a container which is running. But let's do something where we can actually see or get into the container itself. So for that, I do a Docker run, an interactive mode, the same image path, and I'm also going to basically run a PowerShell command at the end. So when I do that, we're going to go into a shell of the container itself, right? So the shell what you're seeing here is not the command prompt of the host machine. It is actually the command prompt of um, the container. As you can see, when I type host name, it's actually giving me some random value and I do a get process, I get a list of process, and you see there's a lot less processes than what you would probably expect on your machine or your host machine. Let's see how many processes are there in my host machine. There should be definitely a lot more. Let me open another command prompt and then see what processes are there in my local host machine. So when I do a get process in command shell, get lot more process, and within the container itself, as you can see, there's just a handful of processes, and within that you can see that there is PowerShell which we are in. And if I do a dir, you actually see a directory structure which is also not matching with the host. I mean, we see a license.txt. Let's see what's that license.txt. Okay, it's actually a copyright message for no, the Microsoft license agreement for Windows container base. So this is definitely the container storage. So if I look at this drive or contents in my host system, definitely going to have a different directory structure. As you can see, host name is different. And then if I actually go to the C drive, let's compare these two. And I can see that directory structure on my host machine, it's actually quite different. So where is this directory structure coming from? So where is this Docker storage located? So in order to actually understand that, what I did was like basically try to find out where these files are stored and how it's actually stored. So because my Docker is installed in C drive, I was expecting that no, by default all the Docker images and Docker container stuff, everything actually resides in C drive. So I downloaded a utility called Spacemonger. It's an interesting utility which gives you a tree map showing how much space or who's occupying how much space in your C drive. So it's quite interesting because it actually tells you which folder has is the biggest culprit when you want to actually try to clean your system, trying to find the biggest files or directories is quite helpful. And then it also gives you the option of digging right into it. So if you find a big folder, you can actually double click and go into that, again see the distribution of the contents within that. So this way you're going to actually find basically who is the biggest culprit if your drives are running out of space. So using the same thing, basically I'm also expecting that all these Docker images, whatever I just showed a few minutes back, that each of them being 4 GB and 1 GB, etc., should have already occupied a good amount of space, and we should be able to find out. And there you go. So there's actually a Docker within the all users. Go to the directory, let's see. If you go to all users Docker Windows filter, they see a lot of different directories. Basically looks like grids. If you look in one of those, we actually see a vhdx file, which is basically know, um, a mount file which you can actually mount as a drive in your system, right? And other than that, we also have a lot of other files like system32, Windows folder, program files, and then hives are nothing but registries and a lot of other files as well. So this is actually the container file system being implemented by Windows to basically mimic or emulate what Linux has done already. Because natively NTSC, um, the native file system of Windows doesn't actually support the doesn't support the union file system. So what they have done is basically they have started with a base image, like a core or a starting point, and on top of it they actually built layers. So layers are nothing but directories which has only the diff files. So each layer is actually mounted one top of another. So when you get a view, you actually get basically a union of everything. So only the diffs are actually combined to get the final image or the actual current image what you are actually seeing or what the doctor actually sees. Right, so you for every time, every change you make, you actually keep creating a layer, and these are all the layers what you have. And then good part of this system is that most of the layers which are common can be reused, and this saves space. So basically, if you have an image which is, let's say, IAS server based on Windows Server Core, and let's say you have another image which is also based on server core, so the server core layer actually gets reused. So this way it's actually just the differential which actually consumes space on your hard disk, so it's very efficient in terms of actually creating only the delta. So let me exit out of this command prompt inside the container. So once I exit out of this, if I do a docker ps, I shouldn't actually be seeing this container. So let me do docker ps, and as you can see, there are no more containers which are running. Okay, let's try to actually get the actual IAS image and probably try to install an IAS now. So in order to find an IAS image, let's go back to Docker Hub. So we can simply search for IAS, and we can actually see this Windows IAS, and then basically that is actually based on Windows Server Core, as you can see here. So this one actually gives you no basically it's the same image of what we have. So basically the tags here indicate like what all different versions are present and corresponding to different builds. And then if you're you need to ensure that your builds are same as your host operating system if you're using Windows 2019. So let me copy or use the command copy command there to actually copy the image, that command, and then the tag what we need. And let's try to pull that, and hopefully it's going to be um, smaller in size because it's actually based on the server core. So it should ideally download only the delta part of the IAS. So let me pull that. So I'm actually going to give the Windows Server Core, um, the LTSC 2019. Okay, it takes a while. So I think it's taking a while. Let me resume once the download is complete. Okay, if you actually go back to the Docker Hub, you would find information on how to use this image. Here they are actually saying like how you can actually create a Docker file. A Docker file is just a build file. It's just a sequence of commands where you can actually create it as a Docker file, and each line actually execute just like as if you're typing the docker run command. And then as you can see here, basically they're trying to remove the inet pub ww root, and then basically copying the content which is on the container, which is supposedly the ASP.NET web page into the container itself, and then they're going to build that. So docker build um, actually uses the docker file and then builds the image, and then of course run the image. So let's copy the command run image, and then let's basically uh, run the image and see what happens. And if you actually see the run command, it's Docker. If you see the Docker images, I think we already have it downloaded. So we can actually run the Docker run command, and we can copy that command from the help here on the Docker hub. Let's copy that so that we don't make any mistakes, any typos. So there you go. So we have Docker run command and we have Docker D. Uh, what this means is basically minus D hyphen D says that we are in detached mode. Hyphen P actually is the port mapping, so it's actually mapping 8000 of the host port to 80 of the container port. Let me change that to 8010, and then I'm giving a name of the container to be like my running IAS site, right? And finally the image name itself. So in which case, in my case, an image name has to be the long name because I don't have that named here. So I need to actually type mcr.microsoft.com/windows/server core :ltsc 2019. Yeah, sorry, IASC and then the Windows Core LTSC 2019. So as soon as I hit enter, it's actually going to go and then launch a website. So if I see Docker PS, you would see that there is a site running, and I can actually browse to that um, Internet Explorer to see whether I can access the website. Okay, now if I actually run Docker PS, I should actually see the IAS server running. Yeah, there you go. So you have my container running. So now let's go to, let's open up a web page, and if I actually go to my local host and go to my 8010, there you go. So Internet Information Services. So what just happened? So basically, if you see in this command, the port 80 of the container is actually mapped to my local um, host 8010. So the moment we actually say localhost 8010, it's going to get redirected to port 80 of the container. And that's where you are actually seeing the IAS website here. That completes our session on IAS. We're going to go next look at the database. Okay, before we actually go into database, basically I wanted to show you something more in IAS. Like basically we saw how easy it is to install a default IAS web server. However, usually we want to actually customize this with our own application, right? I mean, we want to actually host our application. So I'm just going to show you how easy that is. So I already have a sample application. It's a solitaire app. It's just um, just a HTML page with some JavaScript, and that's about it. So it's just a web page which will allow you to play the solitaire game. So how do we actually install this when we actually configure IAS? I want this application to be hosted and not the default IAS application or page, right? So the Docker hub already has this information. So they have given something called a Docker file. So what is a Docker file? So Docker file is nothing but a sequence of steps. So if you want to actually create an image and modify the image and before you use it. So far what we have been seeing is like, no, we download the image, we just run it. We don't make changes to that. So now we downloaded the IAS image, basically the default IAS image. So when you say Docker images, we have the Microsoft.com Windows Server Core IAS latest image, and we used to run that by default. So what if I actually want to use this image, try to copy my content and save that as an image and use that image basically. So when I bring up, basically the server starts with my application. So that's why we actually use a Docker file. Docker file is like basically a sequence of steps. So in here, let me copy this to my text pad, and then I can actually show you. So let's create a Docker file ourselves, right? So let me zoom this. Let me zoom this a bit more. Okay, so this is the Docker file example which they have given already. So what it is saying is from this image mcr.microsoft.com/windows slash serverco slash IAS. Basically bring that image or pull that image. On that image, run PowerShell with this command. So it's actually saying like no, remove all the contents of www root, and then set the working directory as inetpub www root, and then copy the content from my current folder, basically wherever the Docker file is present. I'll copy that content into this working directory. So let me actually copy my application into that. So let me copy this solitaire app into my place where I'm actually creating a Docker file. Right. So the reason why we want to copy here is basically Docker file does not allow you to copy. Docker does not allow you to copy files from relative path or paths basically outside of the place where Docker file itself is present. So let me actually name this as solitaire. Instead of content, I will actually give solitaire and then do a, I'll just call this Docker file, right? So So now I have a Docker file. So now basically we want to use the Docker file. So in here they have given these two commands, Docker build IIS site. So let's copy that and then go here, and then as you can see my Docker file is already present here. So let me clear the screen, and I'm going to build my website. So I will say solitaire. So what I'm saying is like basically build using the Docker file and then build in this current directory, and then use the tag for the newly created image. Please use the tag solitaire IIS site, right? So let's do that. As you can see, step one is basically it's downloading that mcr.microsoft.com Windows Server Core IAS image. We already have it, so that step one is done. Step two, it is actually running a PowerShell command to clear out the contents. Each of these steps actually are baked into the image. So these things are like considered as layers. So every step becomes a layer. Then it actually does a uh, setting of worker directory to inetpub www root, and then it's actually if there are intermediate containers which doesn't go with this. It just removes and cleans up those containers. And in step 4, it's actually copying the solitaire contents into the www root directory, right? So now if I actually see Docker images, we have a solitaire IIS site repository, right? And by default, it's tagged as latest, right? So now let's actually run that image. And to run this site, let me copy this command. It says copy. Okay, so in here, I'm actually saying docker run minus the hyphen D is basically for detached mode. I mean, I don't want to attach this command line command prompt window with the instance. So, and then there is a port mapping hyphen P 8080. So I'll change this to 8010 on my host. It maps to default port on the container, and I'm giving it a name. So basically, my solitaire site, and then here is what we need to give the image name or the repository name. So I will have it as solitaire dash is site, and if I don't give a tag, it's by default taken as latest. So now I'm actually running this image. Now if you actually see, there is a container which is running. So let's go to browser and then localhost. There you go. So I have my solitaire app which is running, right? So it's pretty much very easy to push your contents into the um, like into the Docker container using a Docker file. So Docker file actually creates an image. As you saw here, it created a solitaire IIS site, right? Okay, so that kind of concludes our mm, creation of IAS, deployment of IAS in containers.